5 grams in healthcare, revolutionizing the medical industry. Title: 5 grams in healthcare, revolutionizing the medical industry. Introduction, 150 words. The advent of 5 grams technology has sparked a revolution in various sectors, and the healthcare industry is no exception. With its unprecedented speed and capacity for data transfer, 5 grams has the potential to transform the medical landscape in countless ways. In this article, we will explore 5 significant ways in which 5 grams is transforming the healthcare industry. 1. Enhanced telemedicine, 300 words. Telemedicine, the remote provision of medical services, has already made healthcare more accessible for many patients. However, the implementation of 5 grams will take telemedicine to new heights. With e-help of 5 grams, healthcare providers will be able to remotely monitor patients in real time, allowing for better management of chronic conditions and early detection of emergencies. Moreover, 5 grams will improve the efficacy of remote patient monitoring devices. This level of remote monitoring and rapid data transmission will be especially beneficial for patients in rural or underserved areas who lack immediate access to healthcare facilities. 2. Advancements in medical research, 300 words. The vast amount of data generated in the field of medical research demands faster and more efficient data transfer and analysis. With 5 grams high bandwidth and capacity, researchers will be able to collaborate more effectively and process complex data faster. Furthermore, 5 grams will enable the development of increasingly sophisticated medical imaging technologies. High-resolution medical images, such as CT scans and MRIs, can be transmitted efficiently, allowing medical professionals to access and interpret them remotely in real time. This capability will enhance the speed and accuracy of diagnoses, particularly in emergency situations. 3. Internet of Medical Things, IoT, 250 words. 5 grams will play a pivotal role in powering the Internet of Medical Things, IoT, a network of interconnected medical devices and sensors. Moreover, IoT devices can alert healthcare professionals in cases of emergencies, allowing for immediate response and potentially saving lives. 4. Remote surgeries and training, 250 words. The ultra-low latency and high-speed capabilities of 5 grams will revolutionize the field of telesurgery. With the ability to transmit data in real time without any delays, surgeons will be able to remotely operate surgical robots with precision, even from great distances. This advancement could greatly benefit patients in underserved areas or emergency situations, where specialized surgical expertise might not be readily available. Moreover, the speed and quality of 5 grams networks facilitate virtual reality, VR, and augmented reality, AR, applications, enabling remote training and education for medical professionals. Surgeons can use advanced VR and AR technologies to practice complex procedures, reducing the risks associated with traditional training methods and improving overall surgical outcomes. 5. Data security and privacy concerns, 200 words. As the healthcare industry embraces 5 grams, it is crucial to address concerns related to data security and privacy. With the increased volume of sensitive patient data transmitted over 5 grams networks, ensure In robust encryption, authentication mechanisms, and adherence to privacy regulations becomes paramount. Healthcare providers and technology developers must work together to ensure that patient data remain secure and protected from potential breaches. 6. Empowering remote patient monitoring, 250 words. One of the key areas where 5 grams is revolutionizing the healthcare industry is in remote patient monitoring. With 5 grams high-speed and low-latency capabilities, healthcare providers can remotely monitor patients' vital signs and health conditions in real time. This continuous monitoring allows for early detection of changes or deterioration in a patient's health, enabling prompt intervention and reducing the risk of complications or hospital readmissions. Through the use of wearable devices such as smartwatches or biosensors, patients can easily transmit their health data to healthcare professionals for analysis. This data could include vital signs heart rate, blood pressure, or glucose levels, as well as activity levels and sleep patterns. With 5 grams, this data can be transmitted instantaneously and securely, providing healthcare professionals with timely and accurate information to make informed decisions about patient care. Patients can also receive immediate feedback or alerts based on their data, helping them manage chronic conditions or adhere to treatment plans. In addition to remote monitoring, 5 grams can facilitate the integration of artificial intelligence, AI, and machine learning algorithms into the healthcare system. These technologies can analyze large volumes of patient data and identify patterns or trends that may indicate potential health issues. With the power of 5 grams, these AI-driven systems can provide personalized recommendations or intervention based on an individual's specific health needs. 7. Improving emergency medical services, 250 words. 5 grams technology has the potential to significantly enhance emergency medical services, EMS. This seamless exchange of data ensures that the right information reaches the right people at the right time, improving the quality of care and potentially saving lives. Furthermore, 5 grams can support the deployment of unmanned aerial vehicles, UAVs, or drones in emergency medical situations. Drones equipped with medical supplies or defibrillators can quickly reach remote or inaccessible areas, delivering life-saving interventions before traditional medical teams arrive. The high-speed and low-latency nature of 5 grams networks enables real-time communication between drone operator and medical professionals, ensuring the correct actions are taken. Additionally, 5 grams can enhance communication within hospitals during emergencies. With the ability to support a massive number of connected devices simultaneously, 5 grams networks enable seamless communication tie-in between emergency departments, operating rooms, and other critical areas. This efficient coordination can lead to faster response times, improved patient flow, and better overall outcomes during emergencies. 8. Transforming healthcare training and education, 250 words. With the introduction of 5 grams, healthcare training and education can undergo a significant transformation. Medical students and professionals can access virtual training platforms or participate in medical simulations, enhancing their skills and knowledge without physical limitations. The high-speed and low-latency nature of 5 grams enables smooth real-time interactions, providing an immersive learning experience. Virtual reality, VR, and augmented reality, AR, technologies powered by 5 grams can create realistic medical scenarios for training purposes. Surgeons can practice complex procedures in a virtual environment and improving their proficiency and confidence before performing them on actual patients. This reduces the risks associated with traditional training methods and enhances patient safety. Moreover, 5 grams enables remote collaboration and knowledge sharing among healthcare professionals. Doctors in different locations can connect in real time to discuss cases, seek advice, or share best practices, fostering a global healthcare community. This collaboration not only enriches medical knowledge but also enables healthcare professionals to provide the best possible care to their patients. 9. Advancing Precision Medicine, 250 words. Precision medicine, an approach that tailors medical treatments to individual patients based on their unique genetic makeup, is a rapidly growing field in healthcare. 5 grams technology can play a significant role in advancing precision medicine by enabling the fast and secure transfer of large genomic and molecular datasets. DNA sequencing, a crucial aspect of precision medicine, produces massive amounts of genomic data that require high-speed networks to process and analyze.